Hi, this is Chen from Northwestern University, International Center for Advanced Internet Research, and we're known for our exchange point in Starlight. And also Stephen Shiau is a National Center for High Performance Computing from Taiwan. The topic we're talking about today is Clonezilla for Open Network Install Environment, which is a OCP standard. So this is the outline for today's talk, and I will cover the overview of Clonezilla for ONIE, switched, and full rack storage, and Stephen will cover the architecture of the software. Well, Clonezilla system deployment and provision is based on the idea here. I think it's been exists for about 10 or 15 years. So we all need a computer backup when you run into any kind of problem. So Clonezilla has been exist for backup systems and a massive distribution over the network, or for the lab setup, or for the data center backup. But in the past, it always focused on backup of all the systems. So Clonezilla has been mature over the years. These have been many distributions, probably in the millions level, every year download. So it's well known in the open source community. Clonezilla for ONIE really is come up. The idea is today our switches is just like a server now. So it's a programmable switch. Now you need to run different program on your switch, but at the same time you have no way to back up. Right now, before the Clonezilla for ONIE, the only thing you can save from the switch is a configuration. So you can save the configuration, but you cannot save the other information or data on the switch. So plus, these days, when you try to build up the whole rack or even the whole data center, when you want to try to do a snapshot of the information, you have no way to actually capture what's on the switch. That's one of it. And when you do backup and restore independent from the operating system, because right now you have to depend on different operating system on the switch to do that. And for Clonezilla, the beauty of it is you can do sector or partition level operation. And the other thing is you can use a single tool to do a network backup as well as a server backup. So you'll ask us, how do we use this, and what's the kind of scenario we're using for this type of tool? So this is one example of it. This is the international P4 experimental network, which includes 4 countries, 10 sites, and our partner in the actually local is the Amsterdam. Is SurfNet, is one of our partner, and they form a collaboration for P4 testbed in Netherlands. So there's 3 university and plus the SurfNet. And actually, the SurfNet, our colleague, also is here, Ronald Vanderpoel. And as you can see, in this complicated system, everybody work together, just like the team here, you can see. NCSC actually is up there in the middle of Taiwan. So there's 4 universities in Taiwan, and 3 universities in Netherlands, and in US, there's probably, I would say 6 to 10 universities participate. And National Lab is also have a commercial company like Sienna. So this is an international collaboration, and the use case is for network testbed, science DMZ, which is DOE, US DOE agency invent the term. Basically, you can bypass the firewall and all kinds of different regular operation network, so you can do high speed data movement. Site DMZ on campuses and research platform, which is a new area, people start expand into it. And next network exchange points such as Starlight in the middle in Chicago. And the other one probably more familiar with for this community is NVMe cloud, network function virtualization cloud with the switches. So all these scenarios can be supported by Clonezilla for ONIE. Now, Stephen.
Can you hear me? Okay, good, okay. So, yeah, first I give you a brief introduction about Clonezilla. Basically, it's used, just save the partition and disk use data, not all the sectors. So it's an image and kernel utility like a Norton Ghost or True Image, and it's released under the GPL license. And so with Clonezilla, you can do the system provisioning, bare metal recovery for Linux, Mac OS, Windows, BSD, something like that. Okay, so in the machine room, as Chen had mentioned that for the full rack, you might have, for the first part is about a computing node, server node, and storage node. That's quite mature, and everybody, for the system administrator, they have their own way to deploy this system. But it's only until OCP project, there's a standard in the network switch, it's called ONIE, Open Network Install Environment, that with this, we can, back up and deploy the network switch together. So the full rack, now you can be deployed, and you can take a snapshot for the state, then keep the state, and you can switch to different tests. Then once you need the previous one or some of the image, then you can just restore it to a full rack, including the network switch configuration, operating system. So it's quite useful when you only have a full rack and you want to do many different kind of tests. You can with these tools. So this is the schematic picture about the one we mentioned. There are two parts. The first part is a node, including compute node, server node, storage node. The second part is the ONIE switch. So that's this one is about the mechanism for the one we propose for the BitTorrent, the P2P mechanism to deploy the computing node, the server node, and the storage node. We have Clonezilla live operating system, and it actually includes some of, so the first part is the one to deal with the deployment system. It deal with the partition table and file system, something like that. And second part is a BitTorrent mechanism to deal with the massive deployment. So with this mechanism later, and we also have a new way to deal with the use data on the file system. It's not the files on the file system, it's the block data on the file system. So we developed another tool with EasyIO and the partition paron that can deal with only the used block on the file system. And it can direct read from the hard drive and write to the hard drive. So with this one, we can solve the issue that insufficient temporary storage space to store the whole file system. It's because sometimes, for your memory size, you maybe only have 32 or 64 gigabytes, but your image file, maybe you have 100 gigabytes, something like that. So you cannot just store that image file on the RAM. And because you want to do bare metal recovery or system deployment, it's the bare metal. You have no way to store the image file on the local file system. So with this new way, we can, with the BitTorrent mechanism, we just directly distribute the block data on the file system to every node. So that's the flowchart about this part to massive deployment on the nodes. If you need more details, please come to our poster, and we'll give you more details. Also, so with this one, we do some of the tests to distribute 50 gigabytes image to up to 32 nodes. And as you can see that for the BitTorrent mechanism, you can see when the number of the client machine is getting more, but the time is still almost keep the same. But for the multicast, you can see that as the node grows, the total time is getting more and more. The overhead become more. So with this one, you can see BitTorrent can deploy in a large number of systems, get a better result. But when the node is small, maybe multicast is better. Clonezilla supports both multicast and BitTorrent, so you can use this one to deploy the system. And you can decide which mechanism you want to use. And OK, that's the first part. The second part is we just mentioned the ONIE switch. Since it was in 2012, the ONIE standard was created by the Cumulus network, and it was adopted by Open Compute Project in 2030. And this switch is a bare metal white box, and it's open source, open hardware. So, there are many distributions that support this ONIE network operating system. And it also can be run on different CPU architectures. So a ONIE switch, when the first time you boot, it's just like a PC to boot, but it adds another layer called ONIE layer. Okay, so after the bootloader is loaded, you have a chance to enter the ONIE layer. And ONIE layer allows you to fetch the installer, then install the image, install the network operating system on the ONIE switch. Then once it's done, OK, this one. Once it's done, then the next boot, it will just bypass the ONIE layer. But when you want to enter ONIE layer again, on the bootloader, you have an option to choose to enter the ONIE layer, and it provides for network operating system interfaces. It's including reinstalling, uninstalling, rescue, and updating. So with rescue mode, we can enter the command line and switch to Clonezilla Live, then start to do the system deployment for the ONIE switch. So that's the flowchart. But first, we have to convert the Clonezilla image to the ONIE image. Then you can keep the ONIE image, network operating system image on the maybe on the HTTP server, FTP server, or local attached like a USB flash drive. And the right-hand side, you can see is just like the regular ONIE network switch. But we will choose to enter the ONIE layer and to load the Clonezilla image. So that's a screenshot about we have taken from the Dell ONIE switch. That one is for the bootloader. During the boot, you find in the boot menu, you can choose to enter the ONIE, and you have different interfaces to enter. We choose the rescue. Then with the rescue mode, you will enter the command line. Then with command line, we can run a command to fetch the Clonezilla image. Then it will run kexit, then switch to the Clonezilla Live. Then you can, just like a regular PC or server, you can just back up and restore. So we have some of the live demo on the poster session. So if you are interested, please go to our poster and we will show you. But it's not in the ONIE switch. It's simulated by the VirtualBox. Okay. So basically that's all, and we have some reference for you. All right.